So, I guess it's over 11 a.m. We can start now. Welcome, everyone. I'm glad we can see you here. A lot of great audience. I would like to welcome you on today's presentation about your journey to cybersecurity with Suricata. Let me introduce you to my colleagues and today's speakers. Shivani is from India and is a core developer, Suricata developer, for quite some time already. She has been working primarily with helper tools to automate stuff. She's been fixing a lot of bugs, and I mean, her personal traits, she loves eating, traveling, and memes, as we all do. Juliana is our second core developer from Suricata team. She joined the Suricata team through Outreachy initiative. Outreachy, she could speak a bit more about it if you are interested, but basically it's about including, I can say, social minorities into tech world. She loves reading, swimming, eating, and memes as well. You can find her on Twitter as well as Shivani. And me, I'm Lukáš, and I'm a PhD student here at Faculty of Informatics and researcher at Testnet. Last year, I've joined OISF as well, to Suricata team to be the core developer. My main contribution was DPDK module, which basically focuses on like accelerating packet acquisition from Suricata. So that's what I focus on within Suricata. As we are all developers, Juliana's main kind of contribution from the developer side is adding support for PostgreSQL, so Suricata can now kind of protect your networks from Postgre attacks as well. And major contribution for Shivani is, I mean, she's done a lot of work in Rust as well. So those are parsers for Suricata, so it can understand even more. Okay, so let's go with the first slide, and I'll hand my word to Shivani. Yeah, it's working.
It is?
Yep.
Okay. Hi. So we are all a part of the Open Information Security Foundation, which is a US nonprofit organization that ensures, for now, that Suricata remains world-class. We are dedicated to preserving the integrity of open source. Suricata is an open source software, which we are also going to talk about later on. And primarily open source security technologies, actually, and the communities that keep them thriving. We also have a very nice community around Suricata within ourselves. Our team and our community includes world-class security, nonprofit experts, programmers, and industry leaders dedicated to open source security technologies such as Suricata itself.
Hi, and we will speak a lot about Suricata, but to introduce it for those of you who are not aware of what the tool is about. So, as we have mentioned, it's an open source cybersecurity tool that helps protect computer networks from harmful activities. It does so by monitoring network traffic, constantly checking for any signs of attacks or threats. It can detect when something suspicious happens. This could be either in intrusion detection mode or intrusion prevention mode. Those are the acronyms that you see there. It can prevent attacks by blocking or stopping harmful network activities before they cause damage. That would be in IPS mode. It can it can and does generate important forensics data for threat hunters and threat analyzers. This is one of our big game changers, I think. And it is, as Shivani has mentioned, developed by a community of experts who constantly improve and update it for everyone to use. So in more visual terms, we like to say that Suricata is far more than just an IDS and IPS tool, because it's usually just described as this, but there's more to that. I mentioned the forensic data, and that's very important because when we think of IDS and IPS, we usually think of alerts, and we think of preventing attacks. But sometimes there's something ongoing, and that's when you need the data to understand what could happen in the future. And this is one of the things that Suricata does well with all the logs that it generates. So we have alerts, it tracks application layer protocol transactions, it tracks network flows, it records PCAPs. For those of you who don't know what that is, it would be if you have network traffic, it can record that to a file, and it can extract files. So if you have a suspicious activity and has a file involved, it can extract that file for you to investigate. And it can work locally and on cloud as well. We wanted to bring this sort of distinction of the domains of information security and cybersecurity in case you are not familiar with those, because they can be a bit confusing. So information security talks about what we want to protect, so it's about the data. And we talk a lot about cybersecurity because we are dealing with networks and with digital data, right? So we are also speaking of the medium where this information has to be secured, and that's why we can talk about InfoSec, but it's mostly CyberSec. And I mentioned ICT because this is the medium where things usually will be happening. And for again, something more visual, say that we have, when we talk about internet, this is silly, but I'll mention anyways. We have private data, we have financial exchanges, so we have all these things that are important to us, and this would be the information. When we have to protect this data or the infrastructure that makes sure that it can go wherever we want it to go, but also be safe, then we are talking about cybersecurity. And this is what I tried to illustrate a bit with that. And it's obviously not just the physical data that we can think of these days, but almost everything, right? We have cars, we have the fuel networks and whatnot. And now we want a moment to talk about open source.
So perhaps some of you are already familiar with the concept of open source, but we still wanted to shed some light. Firstly, when we hear the term open source and whenever we read about it, we mostly come across what it is not, and we get the idea that it's always free and it's always compatible with everything and available for use in any other piece of code. So open source and free software are a bit different. Free software is something actually that is freely available for you to use. But open source differs from it in the terms that it would be licensed. There are many different kinds of licenses available as per your use case. It'll be, well, code will be in the public domain. The code will be open source, and it'll be distributable under the license conditions and terms. Suricata itself comes with GPL2 license. So when it comes to licenses, you also have to think about the compatibility of licenses. Like if your software is GPL2, if you are trying to use another open source library in your software, you have to check that it is compatible with your open source license. So there's more information about all of that over here on this link that you can check out. How it is beneficial is for you as students and for anyone. Actually, this slide is for anyone. It's auditable because it's in public domain, so you can always check what's in there. It's easier to extend because you can just fork the project and you can extend it or to make changes as per your use case. You can do knowledge crowdsourcing. You may not be an expert on certain domains, say testing infrastructure, and somebody might come and help you with adding the testing infrastructure in your code and other things like that. The speed of development can increase considerably if your project picks up. There is cost effectiveness. You don't have to get logged into a certain vendor. You don't have to keep paying the prices, although it's good to donate to open source softwares that you use if you're in capacity to. And there's transparency. You know what's going down in a particular software. If something is breaking, you would likely see an issue about it in the public domain, and you'll know the causes, and you can probably figure out what you can do to fix it on your end if you wanted to. For students, it serves as an open resume. So it's always good to contribute to open source software because it's available for anyone to see. Anyone can actually go on your GitHub profile, any other open source code hosting websites available that you can link to your resume, and they can check how deep your understanding is about something and how much you can do. Your Git profile actually matters if you're looking for a job, if you're a developer or documentation writer. If you do other things, look for other platform to showcase that in an open source way. You have a more visible profile, and you have high chances of getting competing job offers. It can also be by other open source software themselves. So when you work, it actually shows up in your Git profile like it does for us when we work on Suricata. And we also get paid to do that because we have a job in the open source domain. There are many other open source software languages and others emerging, which you can also contribute to, and it'll also add up to your profile. Suricata is open source, as we have established by now. You can check out all the projects of OISF on the GitHub. They are usually, it's mostly Suricata and the helper tools that go along with Suricata to make the Suricata users and developers' life easier. And over to Juliana.
So we want to make this presentation with a hands-on part, but we are also trying to sell Suricata to you, right? Let's not be, let's paint things like they are. So we are trying to show what is interesting about Suricata, why is it interesting to know about it and all of that. And part of it is because it's very well known in the industry. It's used by some big names. Some are very specific, so not very well known by the public, but we have like AWS. They are one of our consortium members, which means that they donate to OISF so we can keep Suricata working, we can keep developing Suricata, we can do work trips and present Suricata to a bigger audience. This also means that Suricata is on the cloud with AWS, so if you use it, you may find it. We're sort of like a firewall with them, so it's a bit different than how Suricata usually works, but it's there. Some other interesting security tools that have Suricata are Security Onion, Selks, which I think Lukáš will talk a bit about. Kali Linux recently also enrolled or listed Suricata as one of the tools that they make available by default. It is natively which means that we have official packages for most operation systems with Suricata as well. Lots of integrators have Suricata, so this means that we have cybersecurity hardware that integrates Suricata because they see the importance of it. It's used by big companies that don't donate to OISF, so you may hear of Suricata in places that are not speaking about that, but they are using it. We have, Shivani has mentioned that we crowdsource knowledge, so we have companies like Emerging Threats who are big names of writing rules that are useful for detecting suspicious activities that generate the alerts. So they have a rule set for Suricata. As I mentioned, it is available in the cloud. Some government organizations use Suricata as well, so the Canadian government, the French government, the Brazilian government, but it's small and probably no one knows about that, but some parts of it use it as well. And yeah, I think that this is it for this part. We just wanted for you to know that a bunch of folks think that this is something interesting to be aware of and to know how to use. And now for academia, we have Lukáš.
Okay, thanks. So yeah, in academia, you can use Suricata in many different areas as well. It's really open, and we've seen that Suricata is being deployed in Suricata, school courses as well. Just recently, a few days ago, Google has produced or made cybersecurity course available for everyone. But this course is actually used in US universities as well. So students directly can learn more about like how does cybersecurity world look like and go into that area of focus. You can find other courses online as well. So if you're interested, it's definitely worth checking out. Then the second area where Suricata can be used in academia is for your school project or thesis, if you are interested. For myself, I can mention I've got several publics, so just reach out and we can discuss. But even if you would have some project that you would like to do to some subject, then you can just reach out and we might discuss the details of the assignment. And then, of course, for researchers, mainly Suricata can be interesting from the point of making it faster, so it can process more traffic, making it harder for attackers to kind of bypass it or somehow trick it to for them to go unnoticed, and basically make it stronger, let's say, at resisting any kind of attack. Suricata is widely used in academia already, but just to give you some examples about our core Suricata team members involved in academia, it's me as I have focused my PhD on accelerating Suricata to process more traffic. Then there is Philippe from France who focuses on making Suricata more secure. He also works together with Telecom Nancy University in France. And then there is Josh, who is by now ex-member, but he has amazing YouTube channel where he posted a lot of educational cybersecurity videos together with our second colleague, Peter Manev. He also led multiple trainings that we offer through Suricata and through OISF. There are also other research and academia use cases, but these are from the team members.
So earlier, Juliana mentioned this term called IDS, which was intrusion detection system. So as the name suggests, that's a mode in which Suricata will try to detect something on your network. So that's also called network monitoring, that Suricata is just sitting there. The setup would be something like this. You are connected to the internet through a router or a switch, and maybe there's a firewall in between. And Suricata will ideally get a copy of all the network data that's coming to your router or switch with the help of a tap or span port. And Suricata will monitor all of that traffic and will generate alerts, metadata, file information, or PCAPs, depending on what you've configured it to do. So in the IDS mode, primarily you're looking for alerts, which means that you tell Suricata a certain set of rules that look for these things. You know, if you see HTTP traffic which contains these certain words, and it's probably coming from this IP address, then you please give me an alert because it could be a possible attack. So there's something like that. Rules is something that Lucas is going to give you a demo of, so you'll see what Suricata rule language looks like. And that's how Suricata will look for things in your network and match it against the rules that it has been provided with and create alerts and all the other things. So yeah, this is the network monitoring mode. Juliana will explain the IPS mode.
We call this active monitoring or IPS, intrusion prevention system, because as Suricata is connected directly to the traffic, also known as in inline mode, it can actually drop or reject traffic when it sees something suspicious. So Lukáš mentioned Postgre, right? When we launched Suricata 7, if Suricata sees something, if you have a rule indicating that if Suricata sees something that looks like someone is trying to exfiltrate data via Postgre, they could drop that traffic and reject that to prevent something like that from happening. So this would be a very basic explanation. And the main difference from what Shivani has shown is that, as I said, Suricata will be in inline mode, so it's seeing the traffic directly. It's not copied for it to Suricata. It can still do all the things that it does in IDS mode, and it will have, as I mentioned, the ability to drop traffic, which means the traffic will not continue. If it rejects, it also sends a message saying that this traffic is not allowed to the sender and or the receiver. And it can pass traffic as well, which is saying, okay, this traffic is something that we know that is not malicious, so don't worry about monitoring this, so you won't have, you won't be wasting so much resources with that.
Okay, and so now the theory is over. Let's do some action. So we will look at the kind of basic cybersecurity exercise, what it might look like, and what you might expect out of it. When I first came into cybersecurity space from like programming background before, it was vastly different. I kind of didn't expect it, and so yeah, just to give an idea of how it actually looks like. But before we jump into the demo, I wanted to kind of outline that Suricata is a command line tool and produces a data. It can produce, vast amount of different data structures and like data types of like either from performance side of things for kind of analysis of your Suricata performance, or for the detection itself, or for extracting TLS certificates. So it can extract a lot of data. But generally speaking, The primary file that Suricata extracts is eve.json. It extracts those kind of events in JSON format. And from that, you can basically process that data by some application. Whatever application processes JSON, then it can process eve.json. Generally speaking, we have few data processing applications that are quite common and that work with Suricata well. It's the JQ tool. It's a command line tool, but it can be good for quick check. But usually, security operational analysts don't really use probably JQ. You can use Evebox as a graphical command line. Graphical interface that's developed by another Suricata team member, Jason. Then we will show that Evebox in this demo. So we will work with Evebox and Suricata. And another option might be Kibana dashboards. You probably heard of Elasticsearch and Elk Stack. So Kibana dashboards are fed by eve.json logs, and those can be basically displayed within those dashboards. You can create tables out of that data. And it's really useful and can be nicely shown in a Celx environment, which I'll show that link later on. But basically, Celx is a pre-packaged environment for you, which contains Suricata, Elk Stack, and Sirius. You have it in one virtual machine, but it can be heavy, as I'll explain later. Eve.json can be then fed to SIEM systems, so some more complex systems for security analysis. Then, if you don't like JSONs, but you should probably like JSONs, then there are other older types like stats.log or fast.log, which are kind of like old school way of outputting things. And you can just query the data through grep or some other text processing tools. But if you want to process the data with some application, you definitely want to use some graphical interface or the JQ tool. That happy face is you when you ingest data. Okay. So somebody reported an incident and gave you a session of like something has happened on the network, and you are supposed to answer these questions. From the questions, we can see that when did the malicious traffic start in UTC? It's probably normal. But if you have traffic and the traffic contains your victim's Windows host name, user account name, what RAM and CPU he uses, it's probably something is very off with the traffic. And then there is most likely some malware. I'll mention this challenge or exercise is for Unit 42. Kind of series of challenges, so you can find even more of these challenges online. And this was also covered by Stamus company to like how to solve this exercise using the Celx, as I mentioned, the pre-packaged environment. Now we will use Evebox as a like to show you what data Suricata produces and how this exercise can be solved. Okay, so you can essentially install Suricata from native DPAs or native package repositories. So you just type sudo apt install Suricata, and then you can install Evebox as well. Or you can install Elasticsearch, but for the like Celx environment, you need at least, let's say, 8 to 10 gigabytes of RAM, so it's quite heavy. Okay. this slide just illustrates what you kind of need to do to install it. So just few simple commands. The first 5 commands is for installing the Evebox, which is the lightweight graphical interface. And the second part is for Suricata. We generally recommend you to add our repository, even though it's like in Ubuntu default PPAs. It's still recommended to add our private PPA because in the Suricata official PPA you will get the latest version always, while as we don't have control about what distributions put into their PPAs, so you might get the older version of Suricata. You will just update it and install it, and Suricata Update is a tool for updating those rules, basically, which are used to detect malicious traffic on your network. So what do we want to do during the demo? We will open the PCAP. We see a lot of data. We'll open Suricata with the PCAP, but without any rules. So in this case, we will only see that Suricata does not detect the malicious activity. It only kind of creates evidences of the traffic on our network. It produces some data, it extracts the files and everything, but it will not kind of point us to the malicious activity. And then we can explore what Suricata outputs, and then we will focus on the solving of the exercise. These are kind of our quick commands. We can use that just in a bit, but let me just jump to Wireshark for now. So essentially, here I have the PCAP in zip file. If you haven't solved any cybersecurity exercise prior, they are usually protected, just because, just so you don't trigger your malware in your network by accident. And usually the password is infected. So we've got the PCAP extracted. Oh, no. Let me... Okay, so we've opened the PCAP, and it's looking pretty normal. When we scroll through it, it's some TCP session. Together, that's a lot of data. We have some TLS sessions, some DNS queries. So we are asking what's the IP address of this name. So we probably cannot tell much from this. It's like finding a needle in the haystack. So let's close it for now. And we will help with those commands to kind of feed it to Suricata. Let me mention that you will also have the PDFs, so if you want to try it later on, you definitely can. And let me explain the command line a bit. The first line stands for, like, we are clearing that if.json. If we had any previous session, we want to clear any prior data so that we are on the clean spot. Suricata is the binary itself. Suricata YAML is our default kind of configuration file. We will show that later on, as we will need to edit it a bit more. S stands for, like, what rules Suricata should use. We can also have a peek at those rules as well, just to have an idea of what the rules looks like. The L parameter stands for, like, logging directory, so where that if.json, where that data will be logged by Suricata. And R stands for reading, so we want to read that PCAP file. Okay, so as we can see, the Suricata has read the whole PCAP. It's about 1,000 packets. And this is the evbox command. So the data is loaded. We will go to this site, and we can see that there is like nothing in its clean page. On the top left corner, you have some categories. Let's say alerts. In alerts, we don't have anything because we don't have those rules yet. We will have something there later on. But in the events category, we got a lot of data extracted from the PCAP. Now, what does Suricata can kind of extract? It can extract just the statistics of the what Suricata saw. So these are a bunch of statistics that Suricata can output. It kind of counts like how many HTTP packets it has seen and so on, how many packets it has dropped. It can parse, let's say, TLS sessions, extract TLS certificates if you need it. You can fingerprint it, whatever. When you are within that event itself, you can then click on the IP and see what events were produced by that IP. So we can see this computer has requested a bunch of DNS requests that we can see here in this category. And there is like SMTP, so that's some kind of mail. If we click on it, we see basically from where to where the email was sent. There are more informations from that. And sorting events by IP is one thing, but you can also sort the events by flow. Flow is something that a communication between two computers, but when the communication happens one day and then the other day, it's probably not the same flow. So within Suricata, we have this. This is kind of also differentiated from each other because it has also a timestamp. So this is kind of a hash of that. Like if this is the communication between two computers, within some time period, it produces the same hash. So this is the hash, and we can see in this flow we have 4 events: the SMTP anomaly event, flow event, and SMTP event itself. Anomaly stands for like when Suricata sees some kind of weird traffic, and the flow event is the record of the flow. Okay, considering we've probably covered most of the stuff from what I wanted to show, what are our goals? What other goals are there? So we got goal 3 completed. Now let's try to load Suricata with rules. So we will close the evbox, go back to Suricata, and now I know that Suricata rules should be by default in var lib. Rules, yeah, and then Suricata.rules. Okay, we will run it. It might take some time because it's a rather large file of rules. And just to have an idea of what the rule looks like, it basically says alert if it's an IP protocol from any direction to any direction, and basically there are some other conditions that needs to be matched, and basically then the alert is triggered and is locked to the eve.json output. Okay, so those are the rules files. We got the traffic processed. So we want to look at it again. And now in the inbox or in the alerts, we see that there is an alert of some malware. So it pretty much indicates something is very off. And when we click on it, we see it's probably network Trojan, and it affects Windows XP, Vista, and etc. This is the raw JSON of the event itself. So it can provide a lot of information, but it doesn't really answer everything of the questions. Now, when we click on like what are our goals? So when did the malicious traffic start in UTC? So in the timestamp, and we can essentially just look at when this alert was generated, look at the flow, and we see that this flow was started with this timestamp. So this is the first answer. Now, what are the other answers? What is the victim's IP address? Now, considering we are monitoring our internal network, it's this IP address, so 192.168.127, because it was like our victim has sent the data of our internal network. Now, what is the victim's MAC address? Now, we will need to edit our configuration of Suricata for this, because Suricata can log a lot of data, but to provide some relevant information, some information is by default turned off. So when you want to log more information, you will just edit your Suricata YAML and make sure your hard disks are big enough. Let's look for Ethernet, because we want to log Ethernet as like the MAC addresses, and we will say yes, log those. I'll go ahead and also I want to log also like HTTP payloads or SMTP payloads, because that will give me a lot more information what's going on. So let's also, like when there is alert, also log the payload and HTTP bodies. So basically this means that when alert is triggered, log the payload of that packet. So not every payload is logged, just the ones that are that triggered the rule. Now that we have our Suricata YAML adjusted, we can rerun this again just to reprocess the PCAP, and the new if.json will be generated. So once it's done, we can run ifbox again, and when we click on the ifbox and on the alert, we see that we now see the whole payload, right? That can be very handy, and we can already see some hints that SMTP stands for Simple Mail Transfer Protocol. So essentially, it sends an email with this payload, and when you look at the payload, it says username, computer's name. So what other stuff? Okay, we need to look for the MAC address first. So let's go ahead and look for MAC address. The MAC address is not logged directly here, but that can be easily fixed by going to, let's say, Flow IDE. Look at, let's say, I think maybe TCP will have it. Yeah, and the flow record has it. The Ethernet section, and we can see that source in this case is our victim's IP address. So we want a source MAC, and our source MAC is, for instance, this address. So this is the MAC address. Okay, we are correct. And what is the other information, Windows hostname, user account, RAM, CPU, public IP address, and we can look for that as well. So when we click on the ET malware, we go and see every information that we are asked about is within our payload. This is the public IP address, and we can also see how the malware got this public IP address. You probably know the sites like what is my IP address. So this is exactly what the malware has done. When we click on the DNS, we can see, let's say, this log that queries the IP address of ipfi.org. So it wanted to get the public IP address. Then when we go back to the malware, we see other data as well. After the public IP address, we see the usernames and password as well, and for what application it is, and it repeats multiple times. So again, username, password, and application again, Thunderbird. Down here we got application Edge Chromium, URL coca-cola.com. So somebody was stealing some sweet stuff. And when we click to verify our answers, yes, that's essentially correct. The malware was stealing email and web accounts of the user. And we've kind of filled out our report that this report was really true positive. It was, it really happened on our network, and we can say that the attacker got away with this. This is kind of monitoring, as you've seen previously, like in the IDS mode. Essentially, something has happened, and you know that it happened. With IPS, you could potentially block this traffic if you would see that something is stealing your credentials. Then you can drop the packets and not put it to the outward internet. But yeah, it's up to you how you set up your Suricata. Okay, so this was a quick intro to the cybersecurity exercises. There are a lot more resources for you if you are interested. As always, you can reach out to us if you have any questions. But besides that, we got malware exercises. Malwaretrafficanalysis.net is really good resource for your exercises. You can follow our YouTube channel. We have, or at least we try to have, regular webinars. Last month I had one. This month we already had one focused on hunting ICMP malwares. And then we got one course published on Plural site that's focused on network security monitoring. Another one, as we mentioned, Google Cybersecurity Certificate. That was really a fresh one. It's really published like 5 days ago, I think. Then we got Josh's YouTube channel, where he has a lot of cybersecurity exercises, not only focused on Suricata itself, but other exercises. He now works at Google, so he might be, he's still very much interested in malwares. Then, as you can see, Suricons, those are our annual conferences where we present new stuff around Suricata. I'm not sure about other engineering fields, but within cybersecurity there are awesome lists, which is a collection of like very good tools for that specific domain. So you got some awesome lists for PCAP tools. Suricata have some awesome lists which you can use some supportive tools for Suricata. Or you can, of course, get your custom training, private training, by contacting our email, OISF. Okay, and I guess we can lead to conclusion. And I'm really hopeful that when you walk out of this room, you will remember what Suricata is about, what can it be used for, how does typical cybersecurity challenge looks like. It can be much tougher than we had just here, but it's always interesting to try new stuff. You will remember that Suricata can either prevent attacks, it can detect attacks, it can extract a lot of information as an evidence for later analysis about like that I also hope that you've learned about like what's open source and that there is a big community. I think within Suricata, I'm really happy that we are able to facilitate a great community around Suricata. So if anything is like, if there is any questions, they will just ask the whole community either on our forum or on our Discord. So it's really fast-paced communication. Since it's open source, we are ready to and gladly happy to receive any contributions, either just from the analysis side or from the code side. And yeah, hopefully you've learned how to work with Suricata a bit. So thank you for your attention. Thank you for speakers that were coming in from a long distance to have this presentation with us, and have a great day. Anybody has any questions? Yes, please.
Okay, maybe you said it already, but I'm curious. Can you tell which rules triggered the alerts?
Oh yeah.
In that particular exercise, why those packets were considered a threat?
Okay, that's definitely possible. Just for the record, if we can trigger any rules, I'm sorry, if we can see what rules were triggered by an alert, yes, that's possible. When we go to the e-box, we can clearly see a signature and signature ID, which is more relevant. When we, maybe there is a better way, but the easy way would be to just grab it, right? So it's var lib Suricata and rules, Suricata rules. So you can essentially see that it looks for established flows, so it really wants to have the three-way handshake done. It should be two-server communication. And then there is content, so it's payload matching, essentially. When you have anything in between the pipelines, those are hexadecimal bytes. Then it wants to match content. There are other rule keywords that can be used with in Suricata rule language. There is a whole language built for writing rules. Welcome. Yes, please.
Can you detect traffic behind DRs?
That's possible to a certain extent. You can have, it's called, let's say, you can detect the traffic based upon TLS handshake, because TLS handshake is still unencrypted. So you can at least see the beginning of the flow, and if you see something is off with the certificate, let's say, or with the there is an SNI, you can detect based on that. When it's really, when you are later on in the session, when it's all encrypted, then you probably don't have much luck with that, but you can still decrypt the traffic if you are able to, if you are in the controlled environment. But usually it's based on the handshake phase.
Second question, how the packets are collected? There is a hardware or what kind of medium is used?
Yeah, so essentially you have a Suricata can be run on any server. So as it is just like a normal application, and it receives packets through multiple ways from network cards. Essentially, from the switch, you kind of, let's say, copy or clone the traffic to your probe, which inspects the traffic. And this is a certain like separate Suricata server usually, which receives the packets, decodes them, and does the detection. So it's commodity cards usually. You can have more specialized cards if you are able to cover the costs, but usually just like Intel or NVIDIA network cards for that. Yes, please.
Is it possible to define the rules for alerts based on some probabilistics, like probabilistic rules? Say that Suricata is like 80% sure that some flow is malicious, so it will trigger alert with just some level of confidence.
I think metadata fields within Suricata rules are quite flexible, so you can, let's say, always trigger this alert, and it will notify the security analyst that it's likely 80% positive, because within metadata, you can put any additional information that you want. Essentially, you can see there are some metadatas, but you can define just your kind of like custom properties. These are kind of the more standardized ones that usually you tag the affected products, but you can also, I believe, like define, let's say, within the rule metadata dot probability 80% or something like that, and based on that alert, I think you can just evaluate your alert.
So it would always trigger alert with metadata, and then it's like responsibility of elk stack or something to evaluate the value of metadata?
I would say so. Otherwise, I can't see other way. Like in 80% of cases, you would trigger this alert. I would rather have the alert triggered every time and just evaluate it later on in the process. But maybe I'm not understanding like the question really, or the problem. Like,
I think I would like to add something. Can everyone hear me? So the thing is that I'll try to complement the rules. If the traffic triggers the rule, this generates an alert. You can have specific keywords to add thresholds, say only generate X alerts in this much time, but Suricata doesn't have, say, an intelligence per se other than the rules. So if the traffic triggers the rule, there will be an alert, unless you say, let's combine this rule with this other rule, which is something that could be done, and then if this rule and this rule are triggered, then I want to see an alert. And the other two rules would not be triggered because you used a keyword for no alerts for them. But Suricata mainly uses rules to generate alerts or drop or reject traffic. It doesn't have this ability to post-process the alerts and say, this is this or that. That would be done by a different tool. I don't know if this helps to answer the question. Well, artificial intelligence is there to do everything, right? So yeah, the Suricata is very good at being integrated with other tools. When you have the JSON, you can be as creative as you want.
Yeah, usually, just to complement, that's what we mean by integrators, that if you have, usually you have a company that uses, let's say, Suricata, but may use other tools as well to complement those data or to kind of act upon the Suricata outputs to kind of provide further insight for security analysts, let's say. So, I mean, if you can feed the Suricata output to the AI model, then it's all fine, and it's probably like, it follows the model that usually is existent in the current workspace, let's say. If you would like to input a packet into the AI model within Suricata, it's a little bit different, but it's always possible. Maybe the question in the back.
When is it used as the IPS, does it have, from your experience, a lot of false positives? And if so, how do you handle it? Does it have some kind of whitelist, or you have to adjust the rules?
Do you want to? Okay. I would rather not speak from my experience per se, because I usually work with Suricata usually on the developer level. But usually what it's done is either you tune your rules. There are emerging threats, open rule sets that are big, but can be, also contain false positives. But usually you put your drop rules on very specific rules so that you are more certain about the false positives. And I believe you can also create a wide list of rules that are, or traffic that are not affected, right?
False positives can happen definitely with IPS.
And then there are lots of ways you will definitely have to refine your rules as much as possible, to tune them. Sometimes you will have to create different rules. And I think there's a lot of work done by the analysts in this case to understand why it triggered and if it's really a false positive or something longer. But as Lukáš said, the three of us, we are developers, and that's part of why it's so good for us that Suricata is open source and has this community, because then we can have threat hunters to jump up and say, hey, this is how we write better rules to reduce the number of false positives. Or there's a bug here that is generating lots of false positives. This has happened recently. And so you should fix this part. I think it's connected to this thing. But yeah, there's no way to prevent false positives.
As a last example, AWS uses Suricata as like next generation firewall, essentially Suricata in IPS mode. So it's definitely usable in production environments. Okay?
I have a question on which base can be rules defined. I mean, it's
Sorry, I'm having trouble hearing the question, but
The question is on which base can be the rule created. I mean, it's only one communication. I mean, like one
No.
connection,
Yeah.
payload.
I got it.
Or it can be, for example, oh, this vector of the attack is the attacker tried this, and after this.
Yeah.
More communications, more connections.
Yeah, definitely. Rules can be created across flows, more flows. We have special keywords for that. It's called xbits, where you can set a variable that this happened once, twice, 3 times across many flows. So rules can be written across flows and not just within one flow. Yes, please.
Yeah, what's the performance picture? How much, for example, maybe in complex rules I can put to the system to monitor, I don't know, 10 gigabyte line?
Yeah. So if we are talking about per core performance, it varies based on the traffic and rules and your settings. So there are some factors, but generally you can expect somewhere between, let's say, 500 megabits to 1 gigabit per core. But like with the, let's say, default settings and with the normal size rule set, I would rather opt for something like 600 megabits per second. I'm sorry? Yeah. Yeah, so Suricata is used as a tool by security analysts that work with malwares. I believe they have their own sources on how to get the malware. But usually you have companies that write those collection of rules, and those can be either paid ones or free ones. The ones we presented here are Emerging Threats. That's a company that has a lot of security analysts, and they write these rules. They have ET Open, basically free subscription, and ET Pro for like the most recent attacks that you can encounter, and you will just do the Suricata update, and it will just fetch your newest rules. So generally speaking, who writes the rules are the security analysts, and you can either write it yourself, but you must have like really good experience with that, or you just use some list of rules, and maybe you can tune them. If something is throwing a lot of false positives, you can tune it to either threshold it, or if you don't think it's really valuable, you can turn it off. So something like that. Does that answer your question?
I would like to add, I think that ET updates rules daily or something like that, so on a daily basis. And Suricata, it's not a lot, but we offer a helper tool for rule profiling. So if you write your rule, you can run Suricata to see sort of how good or bad the rule is compared to a rule set and a specific traffic. But there's also that it depends a lot on the traffic that you have, right?
Yep. Yes, please.
Do you by any chance know the story behind the name Suricata?
Yeah, we just talked about it. I was asked about it in the office just today. And the story is probably like that we got a founder, that's Victor, Julian, and he was together with his friend Matt, and they were looking like how to name this software, and his friend Matt had his, I think it was daughter. What? Yeah, I'll just pass my word to Shivani because he explained everything to me.
She's the senior, so she knows more.
I'm kind of worried about saying it on camera. What if I've got my facts wrong? But yeah, I think Victor developed a small firewall program which he called Victor's IPS or Victor's IDS, something like that, VIPs or VIDs. And then unanimously it was decided that we need a better name. And then one of the now board members had a kid who had this toy, meerkat toy, who brought it to the conference or maybe somehow whatever the setting, and they were like, "Oh, what is this animal?" They're like, "It's a meerkat. What does it do?" "Oh, all these things that we are looking for. It's fierce, it's protective, it's always looking out, and all those things." And then like, "Oh my God, it fits." So, hence Suricata.
Meerkats stand for the community. They are always alert. They sound alerts when something is worrisome for them, and they take turns as a community to take care of the community. So they are really community-centered. They are cute to some extent. They make up for a good name in Latin, right? Suricata. So yeah, it's history now.
Yeah, so that's
And
probably
that
it.
toy still sits in Victor's office to this day. So
What?
that meerkat toy.
Oh,
still
yeah. It's still, Victor takes it to every Suricon conference, and he likes, he puts it on the podium where everybody is speaking, and that meerkat is like always looking at the speaker like this, and the speaker is speaking.
Okay. Any other questions? Right. I guess we can wrap up for today. So thank you for attending the presentation, and have a great day.
Yeah, thank you. We heard you had exams, you still came. Thank you.